IAOM Mid-East Africa takes the challenge as an opportunity and has developed this virtual milling forum. It is indeed an opportunity. With the virtual milling forum, we can reach the entire region, Mid-East Africa. We can share the topics with many more members, and the topics are broader and more international. Marianne has given an overview, and we will talk now on the first day. So let's start with raw material. It's wheat. The first presentation is focusing on wheat quality. Wheat procurement managers and millers know while procuring wheat, the saying applies, you get what you specify, but also it counts what you measure. So for quality, the quality is based on the two properties, gas production and gas retention. For gas retention, the gluten quality and quantity counts. Let's listen to Mark Bason's presentation, New Improved System for Gluten Testing. Mark Bason is the expert in gluten and glutamate. Mark is R&D manager, is leading the R&D team of PerkinElmer Foods in Sydney, Australia. Welcome, Mark, and the floor is yours.
Thank you, Martin. I'll just share my screen. Okay, well, good morning to everyone. Good afternoon, wherever you are. Good evening and good night. It's good to have this opportunity to talk to so many people from all around the world who are knowledgeable in wheat and in milling. And I must say at the outset that I am presenting this talk on behalf of my colleague in Sweden, Mr. Martin Hallin, who is the product manager for the rheology group of instrumentation that we make. Formerly from Perton, we've been acquired by PerkinElmer and are now a much larger group. So I hope that it's your good fortune. Unfortunately, Martin was unable to attend for personal reasons, but we will see how we go. So it doesn't need much explanation for you, and we already saw with that introduction that the quality of the incoming material has a direct bearing on the quality of the outgoing material through your mill. And as the old saying goes, garbage in, garbage out. And so measurement of the quality of the wheat and of the final product coming out of the mill being mixed to the requirements of different customers is important. And that's what I want to talk to you today about. So in wheat, which one of the largest uses of it is obviously for leavened bread, the protein in the wheat is the most important constituent. And this applies both to the quantity of protein, which might range from under 10% to well over 15%, but it also applies to the quality or the performance of that protein during the various processes that may be used to make the end product. So be that bread, flat bread, leavened bread, be it noodles, be it pasta, cakes, whatever, the different end materials that come from the flour that comes from the milling process, they all have some dependency on the protein level, and therefore in the specification that you and your customers buy, this is invariably specified. Now, you will know, of course, the most common way and the rapid way to measure protein quantity is by NIR. And that works very well. And you will also know that depending on how much you want to spend, you can control the accuracy of that measurement as well, down to quite remarkable levels, down around 0.2% standard error on the protein measurement, sometimes even better than that. But as I mentioned, just the quantity of the protein in the wheat alone is not sufficient to give an indication of its suitability for final end use for various products. And so even within a single variety of wheat, you will get strong correlations to end use qualities for most products. But once you mix into a class system or look over a wider range of wheats that are coming in to a system, that predictivity from straight protein to end product quality is moderate at best. So to optimize the system, and herein lies opportunity, so that you get the most suitable product from your mills for what your customers want or need. It's also possible with an instrument that Perkin released a long time ago called the Glutamatic,
المنتج النهائي ينبغي علينا أن نستخدم
as well as the quantity of the protein. And within that protein that I've been talking about, it's commonly termed gluten as being the functional part of the proteins in the wheat, the others being the albumins and the globulins, which are enzymes and so on, which, although they're critically important to the growth of the plant and also sometimes in its performance, the most important protein is the structural protein, which leads to the development of the viscoelastic behavior of the flour when it's mixed with water and developed by mixing. So it's only when the gluten has been developed to an optimum level during a mixing process with the various ingredients that the functionality of the wheat protein can be evaluated. So many have tried over the years to come up with very quick tests, such as with NIR and other methods, to predict the performance of the wheat through a process that emulates either production or what the customer will do with the flour, with some levels of success, but generally it's not very predictive. And as you would all know, invariably the seller of the flour has a bake lab, and he needs that bake lab because of all the different methods available. None of them predict very well the final properties as well anyway as actually baking the product. But if you can measure both the quantity of the protein and also the performance of the protein, you do gain a fairly good understanding of the potential performance of a particular batch or a particular blend of wheat. So, and this is an old slide, and some of the concepts in here have moved on a little bit, but I'll try to outline a little of what happens to wheat protein and the flour itself during mixing. The first point is that the general term gluten is very broad, and a long time ago, the wheat proteins were fractionated, and it was recognized that the structural proteins themselves vary quite widely, and two large groupings of those proteins are known as gliadin and glutenin. Now, gliadins generally are the smaller proteins, the monomers, and they contribute to the viscosity or the mixability, if you like, of the dough during mixing. And the larger polymeric glutenins, which are less soluble but very much stronger, during the mixing process, they contribute to the elastic response and the strength and the structure holding ability of the gluten dough or the dough. So broadly speaking, when they are mixed together, you end up with a three-phase structure called dough, which contains air bubbles which are mixed in, and at the optimum development of the gluten, you get the maximum incorporation, more or less, of the small air bubbles, which become the nucleation points for leaven products anyway. And you still have relatively insoluble starch granules, although some of the damaged starch will be solubilized and plays an important role in feeding the yeast in the process. And the proteins themselves, they unwind and form a continuous three-dimensional matrix, which really creates the entire structure the whole process. The starch is important later in the cooking process because it will rapidly absorb water and then set. And when the glutens denature and lose their elastic behavior, it's the starch which provides the structural integrity to the final products in most cases, provided that they're cooked, of course. I should say it is a general understanding that during the unwinding of the proteins and the alignment of them, and particularly the development of cross-links within and between the larger gluten molecules, we get the development of this three-dimensional structure, but not shown on this graph, but also important is the entanglement that occurs, so that as the large molecules are mixed and come into contact with one another, they can also to some extent wrap around each other, very much like the issue with brushing long hair, which I no longer have, which creates a greater viscosity, if you like. But there's also cross-linking forming mainly by disulfide bonds through various contact points, the amino acids in the proteins. So the whole thing builds up this matrix. And why is it important? Because the stronger the gluten to a degree, the better the end-use properties of the product for bread making, leavened bread making. And so a measure of the gluten quality gives you a measure of the potential quality of the final products from that wheat. Okay, so the glutamatic, the instrument that we are going to be talking about today, is able to measure the quality and the quantity of the gluten in wheat, meal or flour up front. So it provides you with a relatively quick test, about 10 minutes, to measure both your incoming material, if you grind it, and also your outgoing flour or specialty mixes in terms of their protein behavior as well as their protein quantity. So this instrument's been around for a long time, about 50 years. It has been recognised by various international standardisation bodies, which includes ISO and ICC.
وحصلنا على إذن اعتراف من منظمة المعايير الدولية وأيضا من منظمة ICC ومنظمة AACC من الولايات.
It's very well established as a standard technique for measuring the quality of wheat. So because we like to use words like nimble and agile, we decided it was time to update the glutamatic, which most of you would have seen and know that it's quite old in its style. And we have finally given it the overhaul that it's long needed, and we're ready to introduce a new system based on exactly the same technology as the old system. So we maintain the equivalence of the results, but with lots of improvements to bring it up to what really is expected in a modern testing laboratory these days. Okay, so for those of you who might not be aware, I'll go through what the method is and how it works. The instrument takes 2 samples of 10 grams each of either flour or wheat meal, or if you want to test vital gluten that's been extracted from wheat, it's 1.5 grams. And those samples are weighed quite accurately, and then they're placed into a cassette, you can see in the second small picture here, and some saline solution, 2% saline solution at room temperature is added. And then that cassette is mounted into the machine, which has a mixing system, which mixes the dough for a period of time, typically 20 seconds, with just that small amount of saline solution added up front. And that develops a small dough ball. And then after about 20 seconds, the instrument starts to feed through the saline solution continuously while continuing to mix. And what that does is it washes out the soluble components and also the starch, which fall through a sieve through the bottom of the mixing cassette into the beaker, as you see here. And from about 5 minutes, usually 5 minutes of mixing, most of the starch and most of the soluble components have been removed, and you're left with around 3 grams of quite elastic gluten protein, which is agglomerated into a ball. This ball is then removed from the mixing chamber and placed in a centrifuge, typically 2, so you can see 2 centrifuge chambers there. And that then is spun for just 1 minute to remove the free water. But also inside the small chamber in the centrifuge is a gauze or a sieve with small holes, and the spinning action, which imparts about 2000 G-force to the sample, forces some of the sample to migrate through the rather fine sieve, so that we end up with 2 fractions: a fraction which passes through the sieve, which is the weaker gluten or softer gluten, more mobile, and the stronger residual gluten is left sitting on top of the sieve. And we weigh both that small fraction which passes through, and then we collect and add the residual stronger component which has not passed through, and combine them, so that we end up with 2 weights here: the through weight and the total weight of the wet gluten. And then some users, not all users, move on to then dry the gluten in basically a pancake or waffle maker. That takes either 4 or 5 minutes, depending which method you're using, and we weigh it again. So yeah, it's not really shown here, but basically you end up with your sample divided into 2 sections: weighed, recombined, dried, and then weighed. So you end up with 3 weighings from the sample of gluten which has been extracted, developed and extracted by the mixing and washing system of the glutamatic. And from that we can define the total wet gluten, which is a measure of the total protein and the water that it binds, and then the dried version, and also the gluten index, which is simply the ratio of the amount of gluten that passed through the sieve, the weaker amount, the residual gluten to the total weight. So samples that give close to 100% in their gluten index are strong samples, strong gluten samples, and samples that give lower values allow more sample to pass through that sieve and are generally regarded as weaker. So moving on to the instrumentation and what's new, just showing you some of the screenshots from the instrument. So basically you start it up and select a method, and most people will just run this flour or this meal method. If you don't want to measure the dry weight, you just choose flour or meal without weight. There are some unique methods that have different aspects, like they use water instead of saline solution to wash the sample, or they mix for longer, or they wash for longer, and so on. And so you can also create your own methods to suit your own needs, and a method for vital gluten. So it's quite flexible, but most people will be running these methods at the top here. And you simply load the sample up as you saw before. If you wish to record and correct the results for moisture content, you can do so here, enter some sample information. And the one thing that I haven't mentioned yet is that optionally you can incorporate that initial dispensing step where you had to use an external dispenser previously to add typically 4.8 mils of saline solution to the cassette with the sample before you put it in the machine. Now you can get the machine to do that initial dispense for you. And that's not in the standard method simply because that option wasn't available previously, but it does make life a lot easier, and from our testing also gives you more repeatable results, and I'm pretty certain most people, once they try it, will stick with that. Okay, so then the system continues to mix. As I mentioned before, in these mixing chambers with the sieve, you can see here washing through the sample to collect the tailings in the beakers there. And the test runs according to its configuration, which, as I mentioned, is typically 20 seconds mixing to form the dough ball, then 5 minutes washing out the non-gluten components. and it just, the test screens track that and alert you to the status of the test and guide you through the steps involved. And then when it's time to move the sample, the instrument beeps as it did before. You're supposed to be able to load the sample into the centrifuge within 30 seconds, and then it spins it for 60 seconds, and then you weigh. Now, a second attribute of this system, which is different to the previous model, is that depending on the model of the balance that you have, and you can use quite inexpensive balances if you need to purchase one, you can plug the balance into the Glutamatic, and then these little weight symbols will appear. So instead of having to weigh and then write down and transcribe and record all the weight information, you simply put the sample that's either through or total or dried, you put it on the balance and you press the button, and the Glutamatic will read the balance for you. The biggest advantage of that, apart from the obvious convenience, is that it reduces the possibility of transcription errors. And the estimates are, in laboratories, the most common mistakes made are transcription mistakes, and they happen between 1% and 3% of all readings that are written down and then transcribed, and which is quite serious actually. So apart from being more convenient, it also gives you better safeguard on the integrity of your results. Once all the weights that are needed are entered, you click the tick and move on. And same with the drying. Once it's weighed, the drying is done, you do likewise, and it will give you the standard measurements, which from this machine, the total wet gluten content as a proportion of the original weight in percentage terms. So this would be 3.16 grams of wet gluten from 10 grams of flour. The gluten index, which is the ratio of the strong to the total gluten, so higher numbers of stronger gluten, as I mentioned. Then the dry gluten content, if you dried it, and the related parameter water binding capacity. So it gives you those four results, and it will save them for you. And then if you just flick right on the screen, it will move to run the next test, or actually flick left, my apologies. So that's basically the old method, but somewhat modernized. This is just a quick overview of what we have changed to bring you up to date on what's now available. I shall go through some of the advantages. So it's got a 7-inch touchscreen, and it's a capacitive touchscreen like your phone. So it also can tolerate multiple touch and swipes and those sorts of things. Actually, we don't use the multi-touch functionality yet, but we certainly use the swipe functionality on the screen, and it's quite responsive. It's a little bit prone to water, but from our testing, there really is no issue running the machine. But if there is an issue, we also provide a stylus, so you can use that to touch the various parts of the screen. If you splash water on the screen, you do have to wipe it off, generally anyway. So as I mentioned, a balance, which can be plugged straight into the instrument. And then the instrument contains a database. And from our testing, for a heavy user, there's enough space on the flash for about 100 years worth of data. You probably want to back up a little more frequently than that. Okay, so the question will come up, how precise is it? How repeatable is it? And how does it correlate with the old instrument? We haven't changed any of the geometry of the mixing system from the old system. It uses the same hook, the same chamber, the same mixing speed, the same temperature of the salt water solution, the same everything along those lines. And so it's not surprising that it obviously gives the same results, which it does. And so you see the dotted lines here between old and new are, for the various measured parameters, are quite good. And that's what we would expect to see between the old and the new models. And that's from a number of old and new instruments there in those graphs. And they were not significantly different. And then in terms of the precision data, the repeatability and the reproducibility of the system, that it is as good or better than the old system. And as I mentioned, if we use the automatic dispenser, we do tend to get superior repeatability within the instrument. But where we see the main improvements now are between instruments, where we're getting reproducibility between instruments that can be significantly lower than on the older systems, probably because of modernised production technology, where we can control the drawings and the assembly and basically the precision of the overall instrument's construction from one unit to the next a whole lot better than used to be possible, because of the world has moved on in precision CNC milling and so on, which makes it possible for us to produce instruments which are more repeatable one to the next. So that's it. In summary, we finally produced a new instrument. It is a lot easier to use than the old one. If you do get your hands on one, I'm sure you will appreciate some of the improvements. Also, in its connectivity, it's basically network ready. It can plug into your local area network. It can even automatically push out the data from every test onto an SQL database that you set up for the larger companies who are interested in doing that. And we've created Windows software, which basically acts as a bridge, so you can configure what information you want to pass on to the SQL system or not pass on, and so on. It's got this automatic dispensing option, which you can use, which in time, I guess, will find its way into the standards, but it's there for now. And connectivity to a balance. It also connects directly to the centrifuge and knows when it's running a test. And the whole system, which consists of the washing unit, the centrifuge and the dryer, are just more integrated than they used to be in the prior system. Okay, so in about 10 minutes, in a test which is really very easy for someone with minimum training to do, you can find out about both the quantity and the quality of the protein in your wheat sample, and take away some of the riskiness in putting them into your milling system to produce the flour and related products that you intend to produce. So there we go. Still runs the old method, but a little more conveniently and with better integration and data management and so on. And it still is the only system which is approved by the international standards and validated by international ring tests accordingly. There are other, what I might call copy instruments out there that claim they follow the standards, but they don't have the international laboratory testing results to validate that, at least with our standards and our standard numbers. So we claim that we have some preeminence in that, and we've been at it for a very long time, for 50 years. So I come to the end of my talk, and I'd be very happy to take any questions that anyone would like to ask.
Fine. Thank you, Mark, for these valuable insights about the gluten and, of course, your glutamatic. Now, we invite the audience to place questions either by chat or verbally, the way as Miriam explained. Now, before, I know that it may take some time to get the first questions in. Mark, I have a question. You mentioned in your presentation that gluten can be measured only by mixing wheat meal or flour with water in a dough. But there are NIR measurement units in the market which measure the gluten content. How do they work, and how can they say, I measure gluten content?
Yeah, we certainly will accept, of course, that NIR can measure protein, and because that correlates to gluten, the measurements of NIR for measuring gluten quantity are reasonable from NIR What the optical methods can't do is measure the performance or the quality of that gluten. And that's where the glutamatic adds value, where the admittedly more rapid and simple NIR methods really can't measure the performance of the gluten.
So you're saying gluten correlates with the protein and NIR is making a calculation for it?
Yeah, look, I'm not an expert on NIR. I just take the word of my colleagues when they say they have a calibration for measuring gluten. I don't dispute it. But I must say I've never looked into the integrity of that claim, but I think it would be true.
Thank you. Any question from the audience? Then I have a second question. You mentioned the gluten index. We all know gluten index in flour, but also in wheat. But often gluten index in wheat is very crazy, very low. Even on a strong, high protein wheat, you find a strange gluten index. How can you?
Yeah, that's probably true. It's what happens is the bran sticks very strongly to the gluten protein, and since it's not been removed as to the level that it has in a flour, you will get some interference from the bran. I must say the method for measuring gluten in the glutamatic measuring meal, I should say, is largely used, at least in the Australian standards, for wet gluten. They don't commonly measure gluten index in meal.
Okay. We have a question from Omar. Mr. Omar, what is the sifter size you use in glutamatic?
It's 88 micron. This is the sieve or the screen which sits underneath the sample during the mixing process for flour. In meal, we start with an 840 micron sieve and then move it to the other sieve during the test. But for flour, it's 88 micron. In the very old methods, it was a metal sieve and it was 80 micron, but everybody uses the 88 micron sieve now.
Excellent. Then, Dori, what is the acceptable gluten index number in bread making?
Yes, well, I'd have to say others in your audience would have a better understanding of this than me. As I understand, numbers above 60 to 70 are generally considered to be good. I'm not sure if it can be too good if the numbers are too high. We certainly see samples that come up near 100% gluten index. And it's different for durum. The gluten, the glutamatic is very useful for measuring durum quality, but the gluten index numbers that are good for making pasta are much lower. But for bread, I think anything above about 60, 70 is generally considered to be a good number.
Okay, bit low, but it's your saying. Then from
Well,
Hallin, what is the cost of the new equipment relative to the standard one? Just
yeah, they did.
And
yeah.
after you can talk bilaterally.
I can, obviously the pricing questions, because I'm an R&D manager and I don't get involved, but I do know that the price hasn't changed. So it's the same price as the old system, which is a bit of a bargain in my mind, considering there's a lot more goes into the new instrumentation than is in the old instrumentation.
Accept. Do you need a special, that's a question, do you need a special software to export data from the glutamatic machine to another computer?
Yeah, so no, but it depends how you do it. So the simplest way to collect data is to place a USB drive into the one of the spare USB ports on the instrument, and you just hit the USB icon in the software, and it will save the data. If you can export after each test, and you'll get a report in a PDF format. But you can also collect up all the results and then export them all at once. And what that will do is it will give you the reports, but also put all of the results into a spreadsheet for you. And if you export every single file that's on the instrument, it will also export it as a database file that can be read by an SQL database. That's the easy way. For people who have more sophisticated networks, and for those who understand how SQL works, we've also created a mechanism whereby you can automatically export the data into that SQL database up on your server live as each test happens. And we have written the software to make that possible. That is just a small Windows client. In fact, you don't even need our software. It just actually finds the SQL database and exports. We'll build the table. But our software provides you with the installation of the SQL, Microsoft's SQL database, and also a window for looking into that data so you can see it and to some extent manipulate it. But our intention with that is simply to smooth the path, make it a bridge into a proprietary system. So all that's available. Yeah.
Okay, thank you, Mark.
بيستخدموا الملح ولا سكر؟ الخبز بيحطوا له ملح ولا سكر؟
Mark, we have a couple of good questions in the chat. So what level of effect does moisture has on gluten test analysis?
Well, the correction to the results is directly proportional to the amount of moisture. So as long as the sample is not too far away from 14% moisture content, it's basically just a linear effect on the results. As a diluting or concentrating of the dry matter, and therefore the amount of gluten in the system. So it's a very simple, a very trivial calculation to work out. And the software will do it for you. If you enter a moisture content which is different to the default 14%, it will make the correction for you.
Excellent. And a question from Stefan. Why are we still using 2% salt solution when most of the bakers use less salt?
Yeah. And why are we still using room temperature when most commercial gluten extraction systems run warmer? They're good questions. We have provided in the system an ability, but you can of course just change the salt solution if you wish to adapt it to your local requirements or optimizations. We also measure the temperature of the incoming fluid, and we do that to warn you if it's gone outside the standard, which requires it to be 22 plus or minus 2 degrees. Is that right? No, 20. It's of that 20 to 24 degrees, I think it's right, yeah. But it's not essential. The only issue is if you choose to use a different wash solution, you're not following the standard methods. And if that's an issue that the standard methods should be updated, then we would be needing to talk to ISO and AACC and the ICC about creating a new method which meets what industry needs.
Accepted. Okay, Mark. Then another question. Oh, it's now jumping up. Just a second. From does the new glutamatic require calibration, and do you differentiate the results with the NIR? Because some NIR measures also wet gluten.
Yeah. So there are some things that have been always calibrated in the glutamatic, and that there's the mechanical spacing of the hook. The space under the hook is particularly important and should be checked. And if necessary, it can be readjusted. The standard is 0.7 plus or minus 0.1 of a millimeter for that gap. And then when during the mixing phase, the mixing chambers are also lowered by 4 millimeters. And there's also a deflection force if it's a very strong gluten ball forming that allows those mixing chambers to deflect downwards. and that has a 2 kilogram force deflection. Those things are set up during manufacturing, can be checked and adjusted by, checked by the user, at least for the gap, and adjusted by service. The only other thing we calibrate is the rate at which the saline solution is pumped through the sample. And we're a bit careful about that now, because if you use it to dispense the initial amount of fluid, which is typically 4.8 mils each side, we do want it to be 4.8 mils, so we do take some care to calibrate that. But basically the instrument, its mechanical arrangement is very simple. It doesn't have complex calibration requirements, let alone secondary calibration development through multivariate methods used in NIR and so on. To which I would only caution, if you're measuring and reporting gluten content by NIR, it should be said in the report that it is an NIR measurement, not a glutamatic measurement, because there is no standard NIR method for measuring gluten content. There is only internationally approved standards for doing it with the glutamatic.
Okay, clear. Now, question from Ayo. Does the method for measuring gluten index for wheat meal differ from the flour?
No, but as I mentioned, it's not really used. We don't, in fact, in the standard setup that we provide for measuring gluten index in wheat meal, I'm sorry, my presentation was a bit misleading unintentionally there. As a general rule, people don't measure gluten index in meals. I mean, you could do it, but as I noted, there is some interference between the bran and the gluten index. You're bound to get a different result than if you turned it into flour and then measured the gluten index again.
Okay, now a very tricky question from Mohammed. What is the mathematical relation between gluten amount in whole wheat, so whole meal test, and the gluten amount in flour of same wheat?
Yeah, that's a good question, and unfortunately I don't know the answer, but you're right. It has to be different because of the amount of bran that's removed, which is a fraction of the initial 10-gram weight. But I must say I've never seen any research to quantify that difference, and it wouldn't be precise because inevitably some flours would have more endosperm and other flours would have more bran as a percentage of the total wheat weight. But sorry, I don't know the answer to that one.
Okay, from Aravona, is there a relationship between dry gluten and flour protein? And
yeah.
Second question, if yes, to what level of confidence can an analyst infer the protein of flour from the dry gluten?
Yeah, again, this is probably a better question for Martin. I would think there's a very strong relationship. In fact, I'm sure I've seen graphs showing that. But that would be a calibration that somebody would have published. I'd have to do some research to find it, but I can pass the question on to Martin if you like, and he can come back with an answer.
Okay. Protein and flour from dry gluten. Okay, just fine. So here we are. I just have to close up 2 short questions. In your presentation, you mentioned and you show also a picture with bread of 20, 30, and 40% gluten. Is that really realistic? I never have seen bread flour with 40% gluten.
I think that was just done for demonstration purposes to show that you can, and remember this is Sweden too, where they do get some rain damage from time to time. Yeah, look, honestly, I agree. You wouldn't put that much gluten, but I think that's just demonstrates the effect of gluten on the loaf volume in that particular case.
Excellent. Thank you, Martin. That were really good insights, good information about gluten. You always learn gluten is gas retention. Without gas retention, no good bread volume. Thank you, Martin. So we have reached the end of the first session.